determination of relative density by using Archimedes principle. Shall we do? Come on. That is ICSE Physics Class 9, 5th chapter, whose B parts numericals, relative density and its measurement using Archimedes principle. Before entering into the numericals, children, you should have the collection of equations that we are going to do in that. Okay, the list of equations which may be required in one or the other questions as we proceed further. So you need to just recall them, summarize them. So let us see what are they. What are the possibilities we are going to see in this? I'm going to tell you. First one, the simple density formula. Density of any substance is equal to its mass over its volume. How much mass the body has and how much volume it has. The ratio of mass to volume is what is density of a substance. For example, consider this is a cube, a cubical structure or a body I have given. Suppose it has got one side as 10 centimeter. If it's a cube means all 6 sides will be the same. One side is 10 centimeter. That is, consider this side is 10. So this also will be 10. We can consider length, breadth, height, all are 10 centimeter each. 10 centimeter. Then what is its volume? Volume will be equal to length into breadth into height. Or we can say a cube side. If it is a cube we can take. Side cube basically. So that is 10 centimeter whole raised to 3 we write. Which means 10 cube is 1000. Centimeter cube is centimeter cube. Cubic centimeter. So 1000 centimeter cube, its volume we can calculate this way. Instead of the body, if it's not a cube, but if it's a cuboid. Cuboid means, children, having the same 6 faces, but it will have length, breadth, which are different. Maybe this way. It's a cuboidal structure. It's having length, breadth, and height are different. At least any 2 of them may be different. Suppose length is 20 centimeter, breadth is 4 centimeter, and height is 6 centimeter. Now we use the equation for finding L into B into H formula. This also, you know, in maths you are studying length into breadth into height. So you solve this portion. I'm not coming with in detail. So this is the way you do, I mean to say, whatever is the mass over whatever is volume. Sometimes for the volume, they will not directly give you the volume. Instead, you may have to calculate the volume if it's a regular body this way. Sometimes it may not be the regular body that you are given. It may be an irregular shaped body. Then we make use of a special or we say device, we say specific gravity bottle, or simply a measuring cylinder we will make use. Look at here. Suppose the body is a stone which doesn't have a shape. It's not spherical, it's not cubical, it's not cuboidal. So any irregular shaped body, first we find its weight in air. So you will get weight. Of course, by using a spring balance, you get the weight. Weight, if it is 20 GF, then the mass will be equal to 20 grams. So weight we are getting using the spring balance, we get the weight, convert it into mass by dropping the F portion, and you write it is the mass. So mass portion, the numerator for the density we got. Now we want to find its volume. How to find the volume? It's not having a regular shape. So what we do is we just hold it by means of a light small thread and place it inside this water present here. Have you seen what I've shown? So what it will do is, initially what was the water level? Suppose if the water level was, this is 10, 5, 10, 11. 11 centimeter cube is the initial level of water. After completely immersing this stone, it is increasing to a higher level, which is equal to the volume of the stone. Volume of stone is inserted, that is immersed into it, means wave from here it increase its volume to this place. So whatever is this difference, will be the volume of this stone. So mass we can just weigh it on a this spring balance, and we can obtain what is the mass. After that, we find the volume by using a measuring cylinder by completely immersing in water, and mass over volume we calculate for density. So different ways how can you find density of a body directly from its mass and volume. I was telling you, for a regular body, regular shaped body and an irregular shaped body. Second thing we have to do, the relative density. Relative density definition itself is density of the substance, whatever is the body whose density divided by density of water. That means we are relating the density of a body to the density of water, the ratio we are taking. So this related value is what is called a relative density, and in short we are expressing it is RD. Is it okay? And in this, the density of water is taken as a constant or a standard with which we compare the rest of the substances, the rest of the body's density, and we refer it as the relative density of that body. Fine. The third thing to remember here is experimentally, how do you find the relative density of a solid? Children, in the above case, I said already, if you have the density of the body and density of water, we know it is to be taken as a constant or as a fixed value standard. So the ratio we can find out. Suppose the density of body is not given. We have to calculate it by means of an experiment. So experimentally, if you want to do, first we weigh the body in air like this way. Using a spring balance, suppose this is a stone, we are finding what is its weight. Suppose 15.1 GF is the weight is coming in air without immersing in water or liquid or anything. Okay. Now, further you find the weight while immersing in water, you will find the weight. Fine. Consider I'm taking this W2 on the right side. I'm taking immersing in water. So place that by tying a thread, that body is to immerse into water and find out what is the weight at that time shown in this spring balance. So there will be a lesser weight. Definitely the weight in water, this is water. In water, the weight will be lesser. You see here 15.1 GF, and when placed in water, it will be 9.7 GF. This, for example, I'm telling. There will be in any case a reduction of its weight, that's for sure. Okay. So using these two values, children, we can find out what is its relative density. Take this relation, in that case, weight of the body in air divided by loss in weight in water. By placing in water, how much weight it reduced, it's shown to be reduced. Actually, it is not actually reducing its weight. It is apparently, it is seen to be reducing. The reason is the liquid offers an upthrust, because of which it shows some amount of reduction in its weight. So what is the loss in weight? Whatever is the weight in air minus what is the weight in water. That is what is called loss in weight. Do you understand? So if the weight in air was taken as W1, the numerator will be W1. If weight in water, if it was W2, then the equation will be W1 over what is in air minus what is in water. That is loss in weight, W1 minus W2. So this is the experimental method in which we have to use the equation to find the relative density of a solid. And what is the speciality? It is not soluble in water. That is why we can immerse it. No, it should not be soluble. Secondly, it should be heavier than water. Then only we can completely immerse in water. Under these two conditions, we can use this method to find the relative density of a body. Clear? Okay. Now suppose you want to find the relative density of a body by using a body, but the situation is the case to another case. The body is soluble in, or we say it is soluble in water, then what we do? We make use of another liquid instead of water. If a solid which is soluble in water, how can we immerse it in water to find the weight? Then we don't take that method. This method we will not use. We will choose another liquid. This is another liquid. This one is another liquid other than water, but in this, the body whose relative density we have to find will not be dissolving. I hope you understand what is dissolving. So in such cases, instead of taking water as the liquid in which we are immersing, finding the weight, we are finding a new liquid, other liquid like kerosene, alcohol, etc., whichever is a suitable liquid we choose. In such a case, the relative density of the solid is calculated as same as before, weight in air. This portion is common. Weight in air you find. Then you find weight in the liquid. In that taken liquid, which is other than water, what is the weight? So two observations we will do, weight in air and weight in that liquid. And the equation will be weight in air divided by loss in weight in the liquid. Earlier it was loss in weight in water. Now it is to be taken loss in weight in liquid. But the equation is to modify. You have to multiply with the relative density of that liquid. So you choose such a liquid in such scenario. If the body is soluble in water, we cannot take water as the liquid. So you choose another liquid whose relative density is known to us. Then multiply with that. So this is the equation. So in variable form, if I write, weight in air is W1. Loss in weight in that liquid is W1 minus W3 into relative density of the liquid. On using this equation, we can find the relative density of a solid which is soluble in water but insoluble in another liquid whose relative density is known to us. Clear, children? And this equation can also be used to find the relative density of this liquid. This also you can find out provided the relative density of the solid you know. Yes. Vice versa, basically. Okay. So, two more things you need to know, children. One is, if mass of a body, in any case, you know, suppose mass of a body is 10 gram. Immediately, its weight, we can write, weight is equal to 10 GF, you can write. Gram, you make as gram force in gravitational units. Okay. And vice versa. If weight is 10 gram, at any time, if you want to know the mass, then you do the reverse. F you drop and write it is in 10 gram. Same is the case with kilogram to kilogram force. If mass is in kilograms, 5 kilogram is the mass, then weight will be 5 kgf. Is it okay? And the same way, there is a relation between density and relative density also. If you know at any time the density of a body, like 7.8 gram per centimeter cube is the density of a body. Its relative density, actually we do density of a body by density of water. Okay. And density of water is taken as a standard. In CGS system, it is 1 gram per centimeter cube. In SI system, it is 1 into 10 raised to 3. That is 1000 kilogram per meter cube. So when we divide with that, actually the same numeric value is coming without the unit because unit gets cut. So 7.8, if it is the density, the relative density will be only 7.8 gram per cc. If the density, the relative density will be 7.8. Okay. So this set of equations, relations, first you write and keep. Whenever the situation comes, we can look into that while solving these numericals. Yes, children.